Today is all about ratios and proportions, okay? And essentially, this will be the first time visibly you will see that building block approach to other subjects, where what we've done in the past really is going to start paying off, okay? So we're going to do 3 learning outcomes today and tomorrow. 2 we're going to do today. So today we're going to do ratio notation and ratios in its simplest form and the links to fractions and ratios. Okay, that's really quite important. Then we're going to look at dividing a quantity into a given unit. So I'm going to roll these 2 up and we're going to do all that in one go today. And then tomorrow we're going to talk about ratios and proportions, and we're also going to talk about this unitary method of solution. Sounds really complicated. It's dead easy because you come across it every time you go to the supermarket. As a quick recap, in previous weeks we've learned numbers and the fact that we've got whole numbers that are called integers, and we learned how to add, subtract, multiply and divide them. The next week we talked about fractions, and all we said with fractions is that it's numbers and it's a fancy way of doing a division. That's all a fraction is. So this links to this, and we showed you how to add, subtract, multiply and divide them. Last week we talked about decimals, and decimals were fractions, because the first column of a decimal is tenths and the second column is hundredths. So this linked to this, which links to that. We then, at the end of last week, talked about percentages. And a percentage was a fancy fraction where we forced the denominator to be the number 100. So a percentage was actually a fraction, which related to that. So everything we're doing relates to each other. There's no such thing as a standalone topic. And today with ratios, you'll see that more than anything. Okay? So what I'd like you to do are these 3 questions as a recap. Okay? So these are things we've done in the past, and we're going to just bring them to the front because we're going to use them today. First question, what is 2/3 of 120? And when we did fractions a couple of weeks ago, we had a process for doing that. Yeah. Oh, we're straight there already. Okay, let's go for it. We'll get this lesson over and done with quick. So, divide by 3. James is saying divide by 3 is our process, which gives us 40, and then multiply it by the numerator, which is 2. So 2/3 of 120, really quickly, is you take your total and you divide it by the denominator, which is 3, which gives us 40, and then multiply it by 2, which gives us 80. The second one, what is 1 minus 2/5? This caught a lot of people out because I didn't actually mention it specifically last week or the week before.
Is it 3/5?
Good. So the answer is 3/5. How did we get 3/5?
We must multiply 5 by 1 to get the down the same as...
Good. So we're talking about equivalence. So I need a denominator of 5. Okay. So what over 5 equals 1? What divided by 5 equals 1? 5 does. 5 divided by 5, that's what it means, is 1. So 5/5 minus 2/5 gives me... Excellent. And we're going to use that a lot today. So you need to realise with fractions that when you take it away from 1, it gives you whatever's missing. So if I've got 2/5, it means 3/5 is the thing that's missing. And that will be really useful today with proportions. Okay. And then finally, simplify 36 over 60. Andre?
Do whatever you do. Like add the numbers, like divided by a number.
Yeah.
You divide 36 by a number and you divide this, like 60 by the same number.
Okay, that's good. So we simplify, we divide the top and the bottom by the same number. So what should we start with?
6.
6. 6 goes into 36 6 times. 6 goes into 60 10 times. Doesn't matter what you start with. 2, 6. It's no big deal. And then what can I divide these by? 2. I get.
Yeah.
Happy? Yeah. So we simplify fractions. Guess what we can simplify as well? Ratios. Okay, which is why we're doing it. So all of these things we will show you today how we're building on previous knowledge, and that's all maths is, building on what we've done before. Okay, so we're talking about these things today called ratios and proportions. What are they? What's the difference between them? What's a ratio? What's a proportion? Anybody?
Ratios, for example, in cake.
Good. Ratios in a cake.
And proportions in math.
So a ratio for a cake might be flour to sugar, 3 parts to 4 parts. And a proportion?
In math.
It's subtly different. A ratio compares the parts. We call these parts. A ratio compares a part with a part. So when you're making a cake, flour to sugar is 3 to 4. That's a ratio. A proportion is an amount, but not with the other amount, but to the total. So if I say to you, 2/5 of the nation read the Sunday Times at the weekend, a proportion is one of the parts and the total. So what's missing? Just did it as a problem. How many people don't read the Sunday Times? 3/5. So a proportion is a ratio, but given to you as a fraction with the total on one of your parts, and you can work out what the other part is. So the important thing of this is, ratios and proportions are the same thing, but they're given to you in different ways. So a ratio compares a part with a part. A proportion gives you one of the parts and the total. So it'll say, just to highlight, a ratio compares parts with parts. So for example, 2 students that pass GCSE Maths, 3 will fail. So pass to fail is 2 to 3. That's our ratio, 2 to 3. Okay? Now, quite important that when you get a ratio question, the first thing you do is you lay it out like this. In other words, write the ratio down with what it is each of the parts means. And it will stop you making mistakes when you're doing your calculations. Some people write the ratio down, 2 to 3, do the calculation, and then give the wrong answer to the wrong thing. So when they give you a ratio question, that will be tied with passing. That will be tied with failing, okay? And you'll get plenty of practice at that. So a proportion, like we said, is one of the parts and the total. So 2 out of 5 people read the Sunday Times. That question we had on the last one, that ratio on the last one, where 2 to 3 pass and fail, it's the same information here, but written as a proportion. So 2 out of 5 students will pass their GCSE Maths. So by logic, how many will fail? 3 out of 5. So 2 out of 5 pass, fail is 3 out of 5. So in theory, I can go from a proportion to a ratio really easily. Okay? So it's important to understand the difference between a proportion and a ratio. Proportions will be given to you as fractions, and we'll see some at the end. Ratios is the thing we're going to concentrate on today, because you can go from proportions to ratios really easily. Okay? So let's do this. Ratios and proportions, pass, fail, 2 to 5. Same thing, written in a different way. Okay. So let's look at some ratio formats. The most important thing is laying the information out. Now with a ratio, you have to write things down as you are given them. So let's just say, I don't know, Lasma and I are going to go into a lottery syndicate. And that lottery syndicate is going to be split in the ratio of 3 to 2. So Pete's going to put in £3 a week, Lasma's going to put in £2 a week. And what we've decided is, whatever we win, we're going to split in the ratio of 3 to 2. Okay? So it doesn't matter what I win, or what I win, and we're trying to work it out. So whatever our type of question is, this is where you start with a ratio question. So even if you have a proportion question, I would expect you to turn it into a ratio one by the end, because ratios will become a doddle. Okay? So the same thing, it's saying the same thing. Pete's going to take 3/5 of the lottery winning. So how much does Lasma get? 2/5. So if you get rid of that, you've actually got your ratio of 3 to 2. Okay? So when you get a proportion question, my advice is turn it into a ratio. Just to show you the link between ratios and fractions. This 3 to 2 ratio means that we have a total of 5 parts. So in theory, the 3 is 3/5 and the 2 is 2/5 of whatever it is we're dividing up. Okay? Pictorially, it looks like that. And when we add our parts together, 5 over 5, we end up with 1 of whatever it is we're splitting up. Okay? That's just something I have to do for you. So let's look at the first type of question. Now the first type of question, and this is Pete's famous cake recipe, talks about the total of something. Okay? So you have to, write down your ratio down first of all. So 3 parts of flour, so I've got flour and sugar, 3 parts to 4. I don't care what type of question it is yet. Every time you write down the ratio first, and then you look at the question and you say, what is the question giving me? Well, in this particular question, it's telling me that my whole cake weighs 350 grams. So the 350 grams isn't 350 grams of flour, it's not 350 grams of sugar, it's 350 grams over here, which is the total of my cake. Yes?
So you divide them by 7.
Good. So if I've got 3 parts of flour and 4 parts of sugar, I've got 7 parts in total. I need to find out what 1 part is worth. So I take, as Andrew says, my 350 grams and I divide it by 7, and it tells me that each part is worth 50 grams. So what I do then is I go back to my ratio that I wrote down and I multiply each side by 50 because I know 1 part is worth 50. So 3 lots of 50 means I need 150 grams of flour, and then over here 4 parts is 200 grams of sugar. And when I add my sugar to my flour, I end up with the 350 grams for my cake. Does that make sense? Yeah? So just because it's the first time we've done this together, let's talk through the process. You're given a ratio, so the first thing you do is write down your ratio, F to S, flour to sugar, 3 to 4. And you write it as you read it, so you don't get your ratios the wrong way around, and I'll show you later. Okay? You then read the question and you decide that the question is talking to you about the total amount. So the total lives over here. It's not the sugar amount, it's not the flour amount, it's the total. So you put your 350 over there, and when you're dealing with totals, you need to add up the number of parts, which is 7, divide 350 by 7 to work out what one of the parts is, and then you go back here and you multiply each side by 50. I wouldn't even bother with that. Right? So let's try one then. You have a go at that one. So I've got 3 male students for every 2 female students. There are 20 students altogether. How many male students are there? So this is less about the maths and more about the process. So if you write it down, the ratio down as it appears, that's your first step. Your second step is deciding what sort of question it is. And the information they're giving you, there are 20 students altogether, is a total. So you know you're dealing with a total stuff. So what's my starting point?
You're going to put like M and F.
Good. Male and female.
Then 3 and 2.
3 males to every 2 females.
Add them together and divide.
You end up with 5 parts, and there are 20 students. So the 20 applies to the total over here. Divide it by 5, so 1 part is worth.
And then times 3 by 4.
Both sides by 4, 8, and 12. So it's asking how many males there are. You've got 12 males. So answer the question at the end, yeah? Good. You're happy with that? Nice easy one, straightforward to get us going. Okay, another easy one, because we're just starting off. I want to know, in a bag of mixed nuts, there are 2 walnuts for every 3 cashews. If there are 15 nuts in total, how many walnuts are there? Okay, so we're just concentrating on totals type questions. They'll get harder in a minute, don't worry. There are what sort of nuts? So I've got a walnut, that's a W. We'll give that a W. I don't like writing the whole word down. What other nuts have I got? Cashew nuts. See? So I've got walnut, and what's the ratio? How many of each am I going to get? What does it tell you? Good. So I've got 2 walnuts for every 3 cashews. That's what we call a ratio. So I don't care what the question's asking me, my starting point is my ratio, and this is what we call a ratio. There are 2 walnuts to every 3 cashews. So what we're doing at the moment is we're talking about dividing up the total. So it says there are 15 nuts. So those 15 nuts, are they all walnuts or all cashew nuts? They're a mixture. So the 15 lives over this side. Okay? So the 15 is talking about 15 mixed nuts. So I'm going to work out, using this information, how many of each I've got. A ratio is a number of parts. So how many parts in total are there? 5. I've got 2 parts and 3 parts, which is 5 parts. If I've got a total of 15 nuts and I've got 5 parts, what's 1 part worth?
3.
How did you get 3?
Divided by 5.
So if I divide 15 by 5, it tells me that 1 part is worth 3. So now when I come here and I multiply each side by 3, it says 2 parts is worth 6 and 3 parts is worth 9. And the question is asking, how many walnuts are there? Walnuts, there are 6. Okay? That's ratios. Here's a question from an exam, and it's split into 2 parts. And it's 4 marks because the second part is a bit of maths that we did in week 1. So it says a car costs £8,000. Anne and Ben share the cost in the ratio of 2 to 3. Anne has saved £150 each month for the last 2 years. Can she pay all her share using her savings? So the first thing I want you to do is work out how much she needs to pay for her part of the car. The second thing is to do with what we did in week 1, where you have to work out how much she's going to save in 2 years. Okay? Okay. So, how do we lay this out? What's my starting point for my ratio? Good, then, Alex.
2 is A, 3 is B.
Good. So you have to write a ratio down the way it is on the question. Anne and Ben in the ratio of 2 to 3. So Anne is definitely the 2, Ben is definitely the 3. And so what am I doing with this ratio?
Add them up and divide it by 1.
Adding them up, I've got 5, and what am I going to divide by 5?
150.
No,
8,000. The car costs £8,000. So I need to divide 8,000 by 5. So this is going back to week 1 where we did log divisions, and it is £1,600 per part. So to work out how much Anne has got, I've got to multiply 1,600 by 2 to get £3,200. Don't care what Ben's got.
Is it 150 times 24?
Good. So she needs 3,200. Let's work out how much she saves. Okay, so let's go over this side, and let's say she saves £150. How many months?
12. No, 24 because it's 2 years.
2 years, 24. So that's the sum there to tell you how much she saves. What's an easy way of doing that? 150 times 24. How can I make that a really easy maths problem? It's unit 2, don't forget, so that you haven't got a calculator, but you can do it in a
grid method.
Yeah, that's right.
Grid method's good. So grid method says 150 by, is it 20 and 4? Is that how you do it?
Yeah.
Yeah?
3,600.
Good. And when you do the grid method, you end up with £3,600. Yeah? So she needs 3,200. She saves
400.
3,600, so she's got 400 quid to go and buy some shoes and a nice frock. Okay? Yeah? And that's 4 marks, yeah? The answer is yes, she can. £400 left over. Just to be smart. Okay? And that's how it works. So that's what we're going to talk about now. So we've talked about total. So the last 2 or 3 questions we've done, we've talked about dividing all the car money up, or dividing up, the totals. What we're going to concentrate on now is we're going to start dividing up the parts. Okay? So Pete's famous cake. I've got flour and I've got sugar in the ratio of 3 to 4. Can you see that? Yeah? 3 parts of flour to 4 parts sugar in the ratio of 3 to 4. It's not changed from the last time we baked the cake. But this time, so we start off with our ratio. This time, when I read the question, I realise I'm not being given a total. It says, I only have 80 grams of sugar. So where does that 80 live then? What's that 80 all about?
Is that 80 the total of all the ingredients combined?
No, it says I only have 80 grams of sugar.
sugar.
How much flour do I need to use?
Oh right, so we do 4 divided by 80.
The 80 is to do with
The
sugar. So it lives under the sugar. It's one of the parts. So the question is about a part, not the total. So the way to do it is when you're given a part, put the number under that part.
You divide by the part.
What? Yeah, so if I've got 80 and I divide it by 4, it tells me I've multiplied it by...
20.
So what do I have to do this side? Because it's a ratio.
By 20.
And what do I end up with?
Yeah, 60.
So I need 60 grams of flour. How much flour do I need? 60 grams. Easy, isn't it? So it's a different type of question. It's not to do with the total. You're given the information for one of the parts. You have to put that information under. That's why I get you to put the letters down, so you know what we're talking about. Okay? So try it with this one. Okay? To get grey paint, I mix black paint and white paint in the ratio of 5 to 3. How much black paint do I need with 6 litres of white, and then the second part with 9 litres of white? Okay. So write the ratio down first, and then decide what information they're giving you. So what are we talking about?
5 and 3.
5 and 3 for what? Don't forget to label them.
Black.
Black and white. So we're talking about paint. Split up in the ratio 5 to 3, black to white.
Underneath white, you need to write.
Good. So we're given 6 litres of white. So the 6 needs to go under there. So what have I done? What do I need to do over here? So in order to create my grey paint, if I've got 6 litres of white, I need 10 litres of black. Okay? So we've got black and white, again, still the same ratio, but this time I've got 9 of white. Really easy, same again, 15 litres of black. Everyone happy with that? Good. Slightly harder because of the numbers, so have a go at that one and see what you come up with. So there's a football match, and the ratio of men to women at this football match is 11 to 4. Okay? How many men were there if there were 2,000 women? Let's do it. So where shall I start?
You put 2,000 underneath the 4.
I haven't got anything yet.
M and W.
Good. So label it, men and women,
Put 11 under the M, 4 under the... Yeah.
11 to 4. So that's the information I was given before I look at what sort of question I've
Got
got.
the 2,000 underneath the 4.
2,000 under the 4 because the 2,000 relates to
500.
2,000 women.
Yeah, you need to count first. 5.
Yeah.
And you times
So
it
to
by-
get that, you divide 2,000 by 4 to get the 500. Yeah.
You do the same thing.
500.
Multiply 11 by 500 because what you do to one side, you do to the other on a ratio.
5,500.
Because the easy way to do that, get rid of the zeros. 5 11s are 55. Put the zeros back.
Yeah.
Yeah? Nice and straightforward, yeah? So we're now recognising there are more than one type of ratio question.
Yeah.
When you talk about ratios, people say add the parts and divide the total. No. This is different. You're given one of the parts and you need to recognise them, okay? This next bit is still about parts, but they go one step further. And they'll ask you, what was the total crowd or the total weight of the cake? So in my famous cake, I've got flour and sugar in the ratio of 3 to 4. What I'm saying is, I've only got 40 grams of sugar in my kitchen. So what is the biggest cake I can bake? So the 40 grams relates to what? Sugar. So it goes under there.
So that'd be 10.
So I multiplied it by 10. What do I have to do over here?
So about 30.
So if I've got 30 grams of flour and 40 grams of sugar, how much is my cake going to weigh? 70 grams. So it's going one step than we've done already. Yeah? You're adding the parts to get a total of something. Okay? So here's one for you. Mary presents a weekly radio show. She plays 5 new songs for every 2 old songs. Last week she played 15 new songs. How many songs did she play altogether?
What? Divided by 3.
Okay,
Labels.
new songs and also new is 5.
Lasma's doing it for you. New soul songs is
5
5
and 2.
to 2. Okay, everyone get that?
Yeah.
So she plays 15 new songs, so the 15 lives
So 5 versus 5.
under the 5.
Yeah, it's like 3.
We multiplied that by 3 to get from 5 to 15. So what do we have to do? The other side, oh sorry, by 3 gives us 6. So the total number of songs that she played that week. Excellent. See how it works? No such thing as a hard ratio question, is there?
Yeah, so like.
Okay. Here's one from an exam. Now if you notice, this is from a Unit 1 exam, so in theory you could use a calculator, but I don't want you to. I think you're good enough to work this out without a calculator. So, Peter and Alice are going to buy a set of golf clubs for their mum. Lucky mother. Okay? They pay in the ratio 4 to 3. Peter pays £224. How much does Alice pay? So it's still a ratio question. The only complicated thing in there might be the maths, the numbers that are involved. So, because it's Unit 1, in theory you could use a calculator, but I don't want you to. What I'd like you to do is have a go at that using no calculator.
You just put like the same things like.
Go on then, James, you have a shot, mate.
Here,
They've got Peter and Alice in the ratio
4.
4 to 3. Good.
Right, 2
224 applies to Peter's share. So all I need to know is,
56.
what have I done?
56.
So those of you who are struggling with the long division, I've got 224 and I'm dividing it by 4. 4 into 2 doesn't go, so I carry the 2. 4 into 22 goes 5 times, which is 20, so it leaves 2. 4 into 24 goes 6 times, so I've got 56. So we've multiplied that by 56, I have to multiply this side by 56.
3 by 50 and 3 by 6.
Yeah, you can do. So 3 lots of 50 is 150, and 3 lots of 6 is 18, so it's 168. If that's how you want to do it, it does it for me. So how much does Alice pay on the answer line? Yeah, we're getting these now. Okay. I'm going to move on to the hardest type of question now. Okay. So we've done totals, and we've done when we're given parts. There's another question that you could be given, which is the hardest one of the lot. And the way to spot these one is, because these are C grade questions, is the question will say somebody does something more than somebody else, or there are more marbles, or they get more money. So the word more is really important on identifying ratio questions about differences. So how does it work? Okay. Well, Pete and Lasma have still got their lottery syndicate going, but she's feeling particularly poor at the moment and can only put £1 in. So instead of having 3 to 2, we've gone down to 3 to 1 as our ratio for us splitting our winnings. Okay. Now, I don't know any of the totals. I don't know what she received. I don't know what I received. What I do know is that Pete got 50 quid more than Lasma. Okay. So the way to calculate these, Andrew?
I've done it like I just found the number who like half difference between like 50.
Yeah.
Half the difference of 50.
50 is a difference. That's the difference in our
Yeah,
winnings.
so I put like 25 for 1.
Okay. How did you get 25? Why did you divide it by 2? Why did you divide 50 by 2 to get 25?
Because you cannot choose like 1 and get 3. I don't know
Yeah,
how to
yeah,
explain.
yeah. Right. So what you've done is, so to explain what Andre's done correctly, is the difference in our ratios, 3 minus 1 is 2. So the difference in our ratios is 2. So we divide our difference in our totals of what we won by 2, and it tells me one part is worth £25. So when we go back here, and we've got times 25 on both sides, that's £75, that's £25, and lo and behold, the difference is that 50 quid we were talking about. So a differences ratio isn't about a total, it's not about parts, it's about the difference in the totals and the difference in the ratios. Okay, so let me show you questions on that so you can practice. This is one of their favourites, marbles. The ratio of blue marbles to red marbles in a bag is 5 to 2. Okay, so even before I start, what am I going to write down? Blue, red, 5 to 2. Because I know it's a ratio question. I know that's a ratio. Then you've got to read the question and decide what the question is asking you. Is it about a total, a part, or a difference? So I read the question. There are 9 more blue marbles than there are red. So more tells me it's a differences one. So the 9 is over here because there's a difference in the totals. So what do I have to do? Divide. What's the difference in these two?
3.
So the difference in my ratios is 3. The difference in my totals is 9. I divide 9 by 3. It tells me 1 of something is worth 3. I go back here, multiply both sides by 3. 5 threes are 15 blue marbles, 2 threes, 6 red, and lo and behold, the difference between 15 and 6 is 9. Yeah? Makes sense. So you need to spot what sort of ratio question is. Because if you notice, up to now, whether it's a totals question, a parts question, or a differences question, it always starts off by writing the ratio down. So the trick to ratios is you've got to spot the right type of question. Okay? So there's one for you. John scores 4 times as much as Ben throwing darts at a dartboard. If John scores 60 more than Ben, what did they each throw? There you go. So do everything that you've done so far. So what's your ratio? What are your letters above your ratio? J and B, John and Ben. What is your ratio? What's the ratio on this one? So I've got John and Ben.
4 and
What's
1.
my ratio?
Would it be 60 and 180?
No.
Like,
The 60
4
is the
times
difference
more.
in the score.
Oh, right.
The 60 is the difference in your total. That lives over there.
Is it like John?
What's my ratio?
Is it John get 4 and Ben get 1?
Good.
Oh.
So this is the first time you've seen this on a ratio question, right? A way of asking a ratio is somebody gets so many times more than the other person. So if Ben scores 1, if John scores 4 times as many, he has to have
4.
So your ratio
It's 3.
4 to 1. So the difference in your ratio
Difference is 3, yeah.
is 3.
About 60.
60 divided by the 3 says 1 part is worth.
20.
We go back here.
Times about
John scores 80. Ben scores,
difference.
and the difference is. This is the 4th type of ratio question, and it's really straightforward. And it's to do with simplifying ratios. So ratios are like fractions where you can get them to their simplest form. So the question might involve this. The ratio of red fish to green fish in the tank, what is it in its simplest form? So what's the first thing I'm going to write down? R to G. And it's really, really, really important you write it that way round. Because if you go G and R, you've lost a mark straight away. Because your ratio will be the wrong way round. How many red fish? How many green fish? So I've counted my fish, and I know there are 12 red fish to 8 green fish. And it's asking it red to green. That's really important. So when you simplify it,
Divide by 4.
divide by 4, I end up with, and that is the lowest term. So here's an example for you. So this is the first time you've seen a 3-part ratio. No different. When I need to make a cake, it's got 200 grams of flour, 100 grams of sugar, and 50 grams of butter. What is the ratio of the ingredients in its simplest form? Okay, so this is our 4th type of question. So we've talked about totals, we've talked about parts, we've talked about differences. All we're doing now is writing a ratio down in its simplest form. So what's my starting point?
You've got F, S, and B.
Good. And then under each of those?
200, 100, and 50.
Good. So I need to simplify it.
The old one is 50.
Well, let's divide by 10 and get rid of those, and then it's nice and easy. That's what I'd do. And then
The old one's 5.
divide by 5. So it's 4 to 2 to 1. That will get you the marks in the exam. If you divide it by 50, that's fine. I'm quite happy with that. Okay, but you're looking 4 to 2 to 1. That's got to be your bottom line. Okay? Good. I'm not going to torture you with videos. I'm going to finish off the lesson, about 10 minutes now, with proportions, and this thing to do with proportions. Now, a couple of weeks ago, if I'd have given you this question, you would have done it as a fraction. And we talked about this instance where Jane gives me some money, and it's £24, and that is 2/3 of what she started with. And when we did fractions 2 weeks ago, we said it's basically saying I'm looking for a total. I know 2/3 of it is 24. So can you remember how we solve that? How do we solve it?
Divide by 3 times
Not quite. We're looking for the original
Right.
amount.
Flip it around.
We flipped it,
Yeah.
so we said 24 times by 3 over 2. So we divide by 2, which is 12. We multiply by 3, and we got 30. So I was looking for a number that when I multiplied it by 2/3 gave me 24, and 2 weeks ago we would have done it like that, and that was in your fractions homework. Okay? What I'm going to show you now is how to do these sorts of problems as a ratio. Okay? Because we know what a proportion is, don't we? So who have we got in our ratio? Jane and me. And what do I get? What's my part? 2 parts. So what's Jane got? 1 part. Yeah, because there are 3 parts in all. That's what a proportion is. If I get 2/3, she gets 1/3. Understand that? The £24 goes under who?
Divide 24 by 2. You found like.
So the £24 is about me.
Yeah.
So it goes under me. So if I divide 24 by 2, it tells me I've multiplied by 12. What do I have to do over here?
That's 12.
So she kept £12 for herself. What did she have to start with?
It's the difference.
Yeah, 36. So she kept 12 for herself. She gave me 24. What I'm trying to do is to show you that if you get these fractions of an amount thing that you're confused with, you can actually lay it out as a ratio, and it can be easier for you.
And is that 2 methods of doing it?
That's 2 methods. So here we flip the fraction and we divide and multiply. Here, what I'm saying is we set it out as a ratio, because a proportion is a ratio. Okay? So if you get a fraction of something, you can say, well, I get 2/3, she gets 1/3. The 24 goes under me. Let's have a look at one. Okay? You can do it either way. You can do it the fraction way, or you can do it the ratio way. So, 12,000 home fans go to a football match. If this represents 3/5 of the total crowd, how many fans were there? Oh, sorry, how many away fans were there? Okay. So, it's a ratio question or it's a fractions question, depending on how you like to answer them. Okay? So, there are 12,000 home fans at a football game. If this represents 3/5 of the total, how many away fans were there? So you're talking about the fraction method.
Yeah.
So what you're saying is, I'm going to flip the fraction to work out what my total is. It's 5/3 times 12,000.
Yeah.
So 12,000 divided by 3 is
4,000.
4,000 times by the 5.
Is 20,000.
Yeah, 10.
So that was my total crowd. It's not asking for the total crowd. How many away fans?
Yeah, so you
Then
take-
you divide that by 12,000. No, take away 12,000.
And it leaves me with...
8,000.
So that's... What we've just done there is the fraction method for doing it.
I think
Let's look at the ratio method.
ratio.
The ratio method says I've got some home fans and I've got some away fans. So what's the ratio of my home fans? What's the ratio?
5,
It's
3,
on how many away fans?
5.
2. It's what's left over.
What? How?
Because there's 2/5 left over.
There are 3/5 home fans. So 3
Oh, yeah.
is there,
Yeah.
which leaves 2/5 as away. What's the 12,000 relate to? The home fans. So what have I done to get from 3 to 12,000?
4,000.
What do I have to do over here? So how many away fans are there? We've done ratios and proportions, and we've divided up quantities into ratios. And we've talked about the 4 types of questions: a total, a part, a difference, and simplifying. And I've also given you some options with proportions, where you can do a proportion as a fraction, or you can do a proportion as a ratio. What we didn't cover much of yesterday are 3-part equations. Ratios are no different to 2-part ratios. If you get a totals type question, it's exactly the same, where if you have a total, you add the parts and you divide the total by the number of parts. So here we've got £9,100 split in the ratio of 2 to 4 to 7. So all you need to do, add the parts up to get 13, divide 9,100 by 13, you work out it's £700 per part, and then you just multiply 2 by 700, 4 by 700, and 7 by 700. So there's nothing different than what you do to a 2-part. Sometimes they'll give you questions with recipes that have 4, 5 or 6 parts. Again, they are no different. You have to multiply each of the ingredients in the recipe by whichever number you're scaling up. Okay? So, here's an example then. A cake is made up of sugar, flour and water in the ratio of 3 to 2 to 5. Work out the amount of each ingredient if the cake has to weigh 500 grams. Okay? Have a go at that one. See how you get on. So how do I lay this out then? What am I going to write down?
3, 2, 2, and 2, 5.
3, 2, 5. What's above them?
Sugar, flour, water.
So that you don't get anything mixed up. Yeah? So don't confuse yourself. before you answer the question, write your ratio down. What sort of question am I answering now?
Add them all together.
Good, it's a total one. So I've got 500 as a total, and as Carol says, we add them up together, we end up with 10. We then work out what one part is worth by dividing by 10, and that gives me 50 grams per part. You go back to your 3-part ratio, and you just multiply each one by 50. So to make a cake that weighs 500 grams, you need 150 grams of sugar, 100 grams of flour, 250 grams of water. One of the main uses of ratios is something called Unitary Method or Unitary Ratios. Okay? All it does is it forces one of our ratios to be the number one. Okay? So it's really useful for things in business, in engineering, in the real world. Every time you go to Sainsbury's, Tesco, Morrison's, if you look at the labels closely, they will say 1p is 2.2 kilos or £4.25 per kilo. So every time one of the two units is the number one, it's a unitary ratio. Okay? So like I say, exchange rates. £1 to every $1.50, yeah, is a ratio. But you're forcing one of the ratios to be 1. The fact that the other one turns into a decimal is irrelevant. When you go to Sainsbury's, what's this? 60 pence per pound for Bramley apples. So I'm forcing the pounds to be the number one. Trip computers on aircraft or cars, 100 miles per hour. I'm forcing the hours to be the number one. Yeah, 1 hour, I do 100 miles. Okay? So that's how it works. So you can actually choose which of the units you want to make the number one. So in this particular example, I'm starting off on a holiday and I'm leaving from the United Kingdom. And I've only got pounds in my pocket, so I want to know how much £1 will get me in American dollars. The exchange rate is usually something like 3 to 2, $3 to £2. So if I want to force the pounds to be £1, I divide this by 2. So if I do that on one side, I divide the other side by 2. So my £1 is worth $1.50. I finished my holiday in the United States and my pockets are bulging with dollars. Because I've been to Las Vegas, I've lucked in. And I want to change dollars back into pounds. Okay? So this time I want to force the dollars to be the number one. So I divide it by 3. And then my ratio is still 3 to 2. I have to divide that by 3. So I know that $1 is 2/3 of a pound, roughly 67 pence. Okay? So that's how Unitary Method works. You force one of the sides to be the number one by dividing it by itself. But because you've divided it by that number, you have to divide the other side by that number. Okay? So here's a method of using it. Okay? Let's say we have a recipe to make tomato soup. And all I'm given is that 6 portions you have to use 450 grams of tomatoes. That's a ratio, it's a recipe. To make my 6 portions, I need 450 grams. Now they're asking me how many tomatoes do I need for 8 portions. Now straight away I'm thinking, oh, I don't like going from 6 to 8. That's a horrible thing to do. So what you can do is say, well, what does 1 portion need in regards to weight of tomatoes? So how do I go from 6 to 1?
Divided by 6.
So what do I have to do the other side?
Divided by
So 450 divided by 6, not hard maths. 6 into 45, 7 times tables, remainder 3, 6 into 30, 5 times. So it's 75 grams. And you're going to need to do these in your head for Unit 2, or write them down at least, okay? 1 portion needs 75 grams of tomatoes. Guess where we're going to go next? How are we going to go? Yeah, back up to 8.
75 by 8.
Yeah, so if I multiply that by 8, good, I have to multiply that by 8. So 75 times 8. Oh, let's think about this then. 75 times 2.
150.
150. So 4 75s is double that. 300. So 8 lots of 75 is 600. So you can do the maths mentally if you can see the numbers. So to make my 8 portions, I need 600 grams of tomato. Now, this unitary method we just talked about, the biggest way by far that you will use it in an exam and in the real world is this thing called best buys. This 1 penny buys you 10 grams of jam or whatever you see on those labels at Morrison's and Tesco and whatever, okay? That is what this is all about. So, let's give you that very example, okay? On the board, I've got 3 jars of jam, okay? I don't really know which one to buy until I work out which one gives me the best value for money. Ignore all this working out, should have deleted it. What we need to be able to do is work out our best buy using the information we've been given. So for jam, for the large one, we've got grams and the price in pence, because I want to know how much 1 penny buys me. So I've got 500 grams of jam for 100 pence. So how much does 1 pence buy me? What have I done?
Divided by 100.
So if I do divide by 100 on that side,
Have to do the same on the other side.
so how much am I left with? What's 500 divided by 100?
5
5.
grams.
So I have 5 grams. So my large jar of jam, for every penny I spend, I get 5 grams of jam. It's not bad. Let's look at our medium jar. I've got grams, I've got pennies, I've got 280 grams and 70 pence. So what am I going to do there?
Divided by 70.
Divide it by 70 by making it 1. So divide by 70 gives me 1 on that side. What do I have to do now?
Divide by 70 on the other side.
Divide by 70 on the other side. What's that give me?
4.
Yeah, divide by 70, I end up with 4 grams. So for every penny I spend on my medium jar, I get 4 grams. Small jar. I've got grams and pennies. I get 100 grams and I get 50 pence.
Divided by 50.
So we divide the pennies by 50 to get 1 penny. Divide the 100 by 50, I get 2 grams. So now I can look at like with like. My large jar, for my 1 penny, I get 5 grams. For my medium jar, my 1 penny buys me 4 grams. And when I look at my small jar, my 1 penny buys me just 2 grams. So my best value for money is my large jar. Does that make sense? Yeah? There's one for you to try. Nice easy one, it's only 2 things to compare. So I'm looking at bars of chocolates. A small bar and a large bar. The small bar is 50 grams, 25p. The large bar, 240 grams, 80p. Which one's the best value for money?
Right now,
50 to a ratio of 25.
You got a ratio of
50 to 25.
50 to 25.
The chocolate rice.
The grams, the weight, and the price. Good.
And then well, 25 to number 1.
Force 25 to be the number 1.
By dividing it by 25.
Good. By dividing it by 25.
And then we divide 50 by 25.
50 divided by 25.
Which gives
2 watts.
grams.
Grams. Good. So your 1 penny buys you 2 grams. You can't. Grams per penny for the large bar. Anybody else like to try that one? So that's the small bar. Got a large bar.
Do a ratio of 240 to 80.
240 to 80 is my ratio of grams to pennies.
Force 8 to be a 1 divided by 80.
Good. Force the 80 to be a 1 divided by 80.
You do it to the other side.
Do it to the other side.
3.
You end up with a nice number 3. So for the small bar, 1 penny buys me 2 grams. The large bar, my 1 penny buys me 3 grams. And then answer the final question: which bar is the better value for money? The large one. Some people actually good. Last one, almost last one of the day. Okay. Got 2 tins of tuna. 1 tin, the large tin weighs 450 grams and 90 pence, and the small tin is 200 grams at 50 pence. Which is the better value for money? Somebody at the back talk to me. Adam, Matt. Somebody.
Ratio
Good. So we're talking about the large tin. We got grams to pennies, and our ratio 450 to 90. Good start. I do like that. Next. Divide the 90 by 90 to get 1. You have to divide the other side by 90. Divide the other side by 90.
5.
Get 5 grams. So your 1 penny buys you 5 grams of tuna. Whoop-de-doo. Let's look at the small tin. Cheers. It's got 200 to 50, which is grams per penny. What do I need to do? Divide it by 50 to give me my 1. What do I do the other side? So I end up with 4 grams for my 1 penny. Happy with that? So my best buy is my large tin, because my 1 penny buys me 5 grams. Happy days? Happy days. Okay, just going to talk a little bit about this last bit. The other places that you use ratios day to day, if you're that way inclined, is maps. Maps are a ratio, and the ratio on a map is the map to the real world. So when you get a map that says 1 in 25,000, what they're saying is 1 centimetre or 1 inch or 1 something on the map is the same something 25,000 times in the real world. Okay? You could get something in the exam that looks like this, which again is a ratio. So a scale on a map is 1 centimetre to 2 kilometres. That's a ratio. And they might say on the map, how far is it from the campsite to the beach? And they've said 6 centimetres. So if you go from 1 centimetre to 6 centimetres, you multiply it by 6. So all you need to do with your scale is multiply it by 6 and say it's 12 kilometres. So maps and map scales are again a form of ratio. Scale drawings are also a ratio. Okay? Here's one for you to do. A plan for a new garden has a scale of 1 inch to 6 feet. The length of the pond is 3 inches on the plan. What is the actual length of the pond in feet? So what have we got? What are our 2 units?
1 and 6.
Inches and feet, and I've got 1 inch is 6 feet. So my plan is this, the real world is that. So what's it telling me I've got? 3 inches on the plan, which is equivalent to, good, multiply this side by 3, 18 feet in the real world. So my pond is 18 feet long. So can you see how we're now using ratios for scale drawings as well? Just one more thing before we finish on ratios. Okay, and that is the fact that measures are a ratio. So when we do units in March, we'll do this properly. All unit conversion is a ratio. So you've got your basic units for length, weight and volume, which are metres, grams and litres. The other words that we use with them, like kilometre or centimetre or centilitre, are what we call prefixes, and they tell us what to either multiply or divide those set units by. So if we were talking about converting something from metres into kilometres, even before I do the conversion, I know that 1,000 metres is 1 kilometre. It's a scale, yeah? It's a ratio. So if I say, oh, I ran 3 kilometres last night, I've multiplied that by 3. If I wanted the distance in metres, it would be 3,000 metres. Can you see? If you need to convert imperial to metric, so imperial's the oldie worldies, the feet and inches, the gallons, the tons and pounds and stuff like that. In March, I'm going to ask you to remember these, not today. Okay? You have to remember 4 conversions from metric to imperial and back. You'll have to know that 5 miles is 8 kilometres. They're not going to give you this in the exam. You're expected to know it. 4.5 litres to a gallon, 2.2 pounds to a kilogram, and 1 inch to a centimetre. And what they might do is ask you about converting between one and the other. So when you get these questions, when we come to March, just think of them as ratios, and you shouldn't go far wrong. So the example I gave my health and social students before this was the weight of a baby. And you might have an old set of scales that said, oh, it's actually from weight of a baby from pounds to kilograms. If you weigh it in, I don't know, 22 pounds, you put it on the scales, it's 22 pounds. You've gone from 2.2 to 22 by multiplying it by 10. So you just multiply the other side by 10. So 22 pounds is 10 kilos. Okay? So I just want to highlight now, striking while the iron is hot, as opposed to bringing it up again in March, that conversions, metric to metric or metric to imperial, are just ratios. Nothing to... Good. So as far as today's lesson's concerned, and yesterday's, we've covered ratios and proportions, how to calculate them, the different types of them.